Okay, slide number 22. Now that you know how to calculate all those errors, ME, mean error, MAE, mean absolute error, MSE, mean squared error, and MAPE, mean absolute percentage error. So having them all, now we can consider two methods of forecasting, and we are able to compare them together and see which one's better. So let's have, other than the other previous method that we used before, naive, we want to consider some other way, some other method, so we can compare them together. The other method we want to do right now is the average of previous periods. So what we're doing here is, for example, in this table, we consider all of the previous values, and we calculate the average of those, and we put that for the next number. So average of these two, for example. Oh, the first one, by the way, it's going to be with no forecast. The second one by the second one, we just put the first one over. We just consider that. This is some sort of rule that we consider here. For third one, we take the average. Fourth one, average so far. And we just continue and go over. So for example, this one here is the average of all those previous values from the first one until number 11. That would be 19. This is the average of everybody. So this is the way. Everything else is exactly the same. If you have, if you can find my Excel file, which I have posted already on portal, you can check. You can download the Excel file and just change this column in here. If you just change the this column in here, just copy this 17, and for this cell in here, use the formula of the average of these. And it's just you can copy all over, because everywhere you go, it has to be average of all those previous values. So if you just follow and you just fill this column here in the right way, everything else should be right, because we just we shouldn't touch any other columns in here. These are the same formulas. The only thing that changes here is the forecast. Okay, so having them all, now we can compare those methods. We're gonna have these numbers in here. These are the errors, right? And we had the previous ones for naive, right? Remember that. And now we can compare and see which one's a better forecast. So which one has generated less error? The one that has generated less error would be a better way. Obviously, this one, average of past values, is a better way, because it generates less errors. Okay, so the other ways, the other ways, the other methods we can use is moving averages and exponential smoothing. So what these means are, the first one, for example, what the first one means is moving averages, is that we consider average, but the average moves. It means that, for example, if we just consider the average of previous two, that the previous two, it just moves with that with that week in here. So for example, in week 4, we just considered the 2 previous weeks and just 2 previous weeks. And in week 7, we just consider the values for 6 and 5, the 2 previous ones. So this is a moving average, because average moves with the time. So average moving average of like 5, you consider 5. Moving average of 10, you consider previous 10. This is how that works. And yeah. And the smoothing method is the one that smooths out these changes. So for example, you have like, these are actual values, right? If the outcome, if the forecast is somehow smoothing this, it's going to be smoothing. So for example, this average, which is the average of previous ones, every one of it's in here, this is a smoothing one. If you plot these two on top of each other, you see the forecast is a smoothed version of time series, the actual values. So that's the reason behind this is smoothing. So exponential is a specific method we use to make the plot smooth. And we have a formula for that. First of all, let's talk about moving averages. So this is the general formula for moving average. And the K here would be K here, I think it should be there. Yeah, K data. So the number of most recent K data values, it's in the formula. So moving average of 4 would be the average of K data, recent data values. Like I said, moving average of 2 would be the average of two recent data values, or two previous ones. Okay, so for example, forecast of value 3, forecast of week 3, right, would be forecast of week 3, if you consider like 2 in here, and use this formula, it's gonna be T forecast of the time series of previous T plus 1. So if you put 3 in here, T becomes 2, and it becomes y2 plus y1 and over 2. Yeah. So don't worry about this formula. If you understand what the method is, it would be much easier. So the formula is just to confirm what we are talking about. But if you understand the method, it would be much easier, trust me. So the term moving is used because every time a new observation becomes available for the time series, it replaces the oldest observation in the equation. Let me just go over on one example. Maybe that clarifies the whole method a little better. There you go. 3 moving average forecast. So this is a 3 moving average forecast method. We consider 3 of previous ones. So every time we move for week number 4, we consider the 3 previous ones. We go to like 5, we consider the 3 previous ones, and the average of those would be the forecast for the next one. So consider this. Just do that, and you're going to be fine. Don't worry about the method. Don't worry about this formula right in here. So now you should be able to generate the forecast, and the other ones are exactly the same. If you have the file, again, the formula is going to be exactly the same. And then again, you should be able to compare these values together. Considering them, you'll see that the 3 week, if you double check. Oh, we haven't done any other method in here, but if you do, like if you consider 2 moving averages or naive, you see that, oh, this one is comparing with naive approach. So if you consider naive version in here, a naive method in here, and do the same thing, you'll see that the moving average approach would be a better or more accurate forecast, because these numbers are going to be less than the other one. But we don't have those numbers in here. So I'll let that part for you. Okay, moving to exponential smoothing. So This method is somehow like the other ones, but we just have a formula to forecast any number. We have a formula, and the formula is just like this. First of all, let's just talk about alpha in here. So alpha is a smoothing constant. It's a constant, is a number between 0 and 1. What exactly is that number? We don't know. So what we do in here is we consider just a few alphas in the formula, and to see which alpha generates a better error, and that alpha would be the best alpha we can use, and we consider that alpha in the smoothing, in exponential smoothing method. So we just try and see. We test a few of alphas because we have computers now. It would be easy because computers can do calculations for us, and we can find the best value. So it's just a constant, a value between 0 and 1. So ft, we don't have actually ft in that formula. Yt, like I said, we consider, I think I said this before, we consider, for the second one, we just copy the actual value. For forecast of the second one would be the actual value of first one. Okay. So forecast of the time series for period t plus 1. So this means forecast of the time series for the period of t plus 1. So we consider t plus 1 because just to make everything easier, because we have the actual value of t in here. So actual value t, the forecast of t, and if you have two factors in here. So the factor here is alpha, and the other one, the factor of other one, is 1 minus alpha. So again, what the alpha is, you shouldn't be worried about that, because we're just going to compute. We're going to just use computers to calculate alpha for us. All we need to know is that it's a constant, there's a number between 0 and 1, and we can find it with computers. These are samples. You can take a look. For example, here, alpha is 1. In case of any problem, alpha will be given. Alpha will always be given. For example, here, constant alpha is 0.1. It's given, so you shouldn't be worried about that. And you just need to use the formula to find out the outcomes. So for example, here, like I said, consider this. Forecast of the second week, forecast of the second period would be the actual value for the first week. So having this table, actual value of the first week is 110. So you can generate 110 for the second. So that would be the forecast. For the third one, we're going to use the formula, and we have 3 in here. So these two are going to be TT. The actual value of week 2 is based on the table 115, and the forecast is going to be 110. So if you put them in the formula, this becomes that, right? And you find out this, and the outcome is 110.5. And if you just continue, you can find out all the values. This would be the smooth version. This one, all the outcomes going to be something that if you plot these two on top of each other, the actual values and the forecasted values, you see that the forecast is smooth. And that's what they call it smooth. So smoothing constant, alpha is always given. So now in this question, you're asked to compare these two values, these two constants, see which one's better. So you just need to use the formula and use Excel file, generate these errors and compare these errors together. And which one's better is the one that generates less error is the better alpha. So for example, here, exponential smoothing with alpha 0.8 provided more accurate forecasts than alpha equals 0.1. Okay, so the next part is pretty straightforward because the method here we use is regression, and for regression we use computers and again Excel program, because that's just you just need to click a few buttons and use some functions and then it generates the formula for you. So you're just gonna have the data set over there and click a few buttons that generates everything for you. And having the formula, you should be able to just build the forecast. So instead of like having a formula just like that, okay, let me find that. Remember that in potential smoothing, if you can remember, in potential smoothing, the formula was that. And over there in regression, the only change that we have in here is that we get the formula from computer. And the formula is the one that generates less error. So we already know how the formula works, because computers just gives us the best formula with the least error terms, not message, sorry, standard error. Not going to get into details because that's related to statistics. So I just wanted to point out that you can use that as well.